Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Sebelumnya yang terhormat Bu Akda dan teman-teman yang menonton video ini, saya perwakilan dari kelompok 2TI22H ingin mereview video tentang laju reaksi natrium, tiosulfat, dan asam klorida. Adapun poin yang kami dapat yaitu bahan percobaan natrium tiosulfat, pengertian laju reaksi, dan asam klorida, dan faktor-faktor laju reaksi.
This next demonstration I'm going to do is one that I've probably been doing for some 20 years. And the first time I saw it performed, I thought, boy, I hope I can do something like that. Because it was so interesting to see chemistry taught with a demonstration and the talking. And Dave Tanis was my inspiration. When I saw him do it, I decided I needed to go to more workshops. But this is a kinetics demonstration that I've since used mostly as a lab. It can be done on the overhead projector and all the students can gather data together, or you can have them do it back in the laboratory. It's a clock reaction essentially.
Pada bagian kali ini, kita akan menjelaskan pengertian dari laju reaksi. Laju reaksi adalah perubahan konsentrasi reaksi ataupun produk dalam satu waktu. Dalam video ini menjelaskan tentang bahan natrium tiosulfat dan asam klorida.
Laju reaksi adalah persamaan yang menyatakan laju reaksi ini sebagai fungsi konsentrasi semua spesies yang ada, termasuk produknya.
Untuk rumusnya, bisa di atas ini.
Sodium thiosulfate, and we've got a 0.15 molar solution of sodium thiosulfate. And we're going to add to that hydrochloric acid. All right, and I've only got the net ionic equation because the sodium and the chloride ions are spectators. This forms solid sulfur, sulfur dioxide and water. This solid sulfur is a colloid. It stays in suspension and it'll eventually block the light coming through my beaker. You may have done this reaction as part of a chemical sunset because there's a nice demonstration people do when they're putting it on the overhead projector and they can see as the colloid forms more and more.
Pada percobaan kali ini kita menggunakan dua senyawa, yaitu natrium tiosulfat dan asam klorida. Natrium tiosulfat merupakan obat golongan garam sulfat yang bermanfaat sebagai obat untuk mengatasi efek samping dari penggunaan obat kanker. Sifat natrium tiosulfat yaitu tidak berbau, tidak berwarna, dan berbentuk serbuk kristal.
Baik, kemudian ada asam klorida. Asam klorida ini adalah larutan akuatik dari gas hidrogen klorida atau sering kita sebut HCl. Nah, ia adalah asam yang kuat dan merupakan komponen utama dalam asam lambung. Senyawa ini juga digunakan secara luas dalam bidang industri. Nah, asam klorida harus kita tangani dengan secara hati-hati karena mengandung Karena mengandung sifat korosif. Nah, seperti pada video yang sebelumnya, di situ dijelaskan ketika kita menganalisis, kita harus menggunakan sarung tangan sebagai pelindung tangan kita sebagai penghindari dari sifat korosif tersebut.
And what I've done is I have 5 beakers, and the beakers have varying concentrations of the thiosulfate. So in the first beaker, of course, I've just got the pure 0.15 molar sodium thiosulfate, and then I have diluted it along the way. And I would give my students a data table like this and ask them to calculate those new concentrations for the other 4 beakers. We're going to add 5 milliliters of hydrochloric acid, and the students are going to observe the disappearance of an X as that colloidal sulfur forms. So we need to time this, and can I get a volunteer? Janet, I'm going to tell you when to start and when to stop. And I'm going to put the sulfuric acid in here and then, hydrochloric acid, and then, tell you to start and then stop. Start. All right, now I'm going to tell you when that X disappears. If you look from the side, you should start to see the cloudiness on the side. All right, now you're looking down. Stop. Okay. How many seconds did that take?
18.68.
18.68 seconds. All right, and what the students, thank you. I'm not going to do the whole experiment for you, but what the students would do usually, if I have them do it as a lab, they'll do each part. And I always warn them. I say to them, start the last one early, because it's going to take longer for that last one to change. And what we do is we start measuring. We put the other ones in. And they will take varying amounts of time to change, and the kids time them. The last one frequently takes like 3 to 5 minutes to change, and so if they don't start that one early, they'll have some problems, but they will get a sense of the rate, and we do the first one early so that the kids get an idea of how to mark that X. And they'll just change it. So it's concentration versus the rate. And let me show you what the data would look like for something that I did do in my classroom. We'll do a cooking show approach to this. This is some actual data that my students gathered. And you see that in this case, their initial one was 22 seconds, and their final one was almost 3 minutes. All right. We're going to look at the graph if we plot the concentration versus time. So if I plot concentration versus time, it's not linear. So I talked to the kids about the fact, well, what about rate? If you're looking at rate, the more time it takes, the slower you're going. So it's really an inverse relationship. Let's look at the graph of concentration versus 1 time. So it's easy for kids to do this now with those graphing calculators, and so I show them how to make lists and use their graphing calculator, and they will get a linear relationship for this. You can talk about the fact that this is the concentration in this case is directly proportional to time. If you're teaching a class where you talk about.
Hai guys, oke. Di dalam percobaan kali ini, dalam percobaan laju reaksi ada beberapa faktor yang mempengaruhinya, yaitu ada konsentrasi, luas permukaan, suhu, dan katalis. Dan juga di sini ada waktu untuk mempertimbangkan berapa reaksi atau berapa waktu yang dibutuhkan untuk kejadian reaksi antara natrium tiosulfat dan juga asam klorida. Oke, kita akan lihat video selanjutnya.
Rate constants, you can say this is first order with respect to concentration. Otherwise, you can just talk about the fact that it's an inverse relationship, but it's directly proportional. And you can ask them, well, how could I test to see what the relationship is with the amount of acid? There's 2 reagents involved, the thiosulfate and the acid. We kept the acid constant. Let's see, could you tell me how to alter the experiment? And that would get them thinking about variables that they'd have to hold everything constant, and except for the HCl concentration, and they could make a similar graph of that. It's a great experiment. It has a lot of extensions. They could even look at the effect of temperature on rate with this experiment. And so I really recommend it to you as something that you can do with your classes, and I hope you enjoy it as much as I do.